Hello everyone, this is Mr. Cunningham, and today we're going to be talking about how to name and write the formulas for ionic compounds. Remember, a few weeks ago we started chapter 7, which talked about ions and ionic bonding. Well, today we're just going to be kind of building on that prior knowledge of how to name those ionic compounds that we were talking about. So try to remember back to chapter 7 and those type of bonds and type of compounds we talked about, like sodium chloride and other ionic compounds. And so let's look at how we can name these ionic compounds that we talked about a few weeks ago.
So before we can start naming ionic compounds, we need to know how to name first the ions. So let's look at cations first. So in naming cations, all we have to do is really just add cation to the end of the word. So sodium we would call just sodium, but then when it loses an electron it becomes positively charged, and that just makes it a sodium cation. So we would just call that ion a sodium cation. Now, when we're talking about naming anions, that's when things change a little bit. So for chlorine, when we name a chlorine anion, we actually call it chloride. And the same thing with sulfur. So all we do is we drop the last syllable of the element name and add IDE. So for the example of chlorine, we drop the INE of chlorine, add IDE, and that makes it chloride. For sulfur, we drop the UR and add an IDE, and that makes sulfide. So now we can actually start naming ionic compounds. So let's look at a few of those. So let's look at KF. So this ionic compound is made of potassium and fluorine. So really all we have to do to name this compound is to do what we just did with the ions. So to name a potassium cation, all we do is start with potassium, and then to name fluorine, all we do is drop the INE and add IDE. So this compound would be called potassium fluoride. So, but we always have to remember is we name the cation first. So when we write chemical or ionic formulas, we'll start with the cation first, and then when we name them, we'll start with the cation first. So that's a rule that we'll have to remember as we go along. So let's look at one more. Here is aluminum and oxygen. So in order to name this, we do the same thing. Even though there's 2 aluminums and 3 oxygens, we don't have to specify that in our naming. That's because these 2 elements have specific oxidation states. And when we start talking about writing the ionic or the chemical formula, this will make more sense. So in order to name this, all we do is what we just did with the last one. We have aluminum, and then with the oxygen, we drop the last syllable, and so we have aluminum oxide. So we would name this Al2O3, the name of that is aluminum oxide. So let's look at another one. So now we're going to be talking about writing the formulas. And this is where we're going to have to keep track of oxidation states. So this one we'll have to really pay attention and make sure that we get this right. So the first one is we're going to write an ionic, we're going to name an ionic compound, or write an ionic compound that's between magnesium and bromine. So this is called magnesium bromide, and so now we're going to write the chemical formula for that. So magnesium forms a +2 cation, so its oxidation state is +2. Bromine wants to gain 1 electron, so its oxidation state is -1. So in order to write the chemical formula for this, we have to do something called the crisscross method, and I'm going to explain that. So in the crisscross method, we take the numbers of the oxidation states. So we take the 2 for magnesium and we'll put that on the bromine. And then we take the 1 from bromine and put it on magnesium. So that might be a little confusing, but as you see this next part, I think it'll make more sense. So we would actually write this compound as MgBr2. And that's because, remember, in ionic compounds, there always has to be a balance of charge. So magnesium has a +2 oxidation state, and bromine has a -1. So that means that if we have one magnesium, which is a +2, then that means we also have to have a -2. So that means we need 2 negative charges from the bromine, so that means we need 2 bromines. So MgBr2 would be the correct chemical formula for an ionic compound that occurs between magnesium and bromine. So let's look at one more. Here we have calcium oxide. So calcium is a +2 cation, and oxygen, or oxide, is a -2 cation. So we do the crisscross method, like we just explained, and so that gives us Ca2O2. But something that we have to remember is that we have to reduce those subscripts. So the 2 beside the calcium and the 2 beside the oxygen, we have to reduce those. Okay? So what we do is we find the highest whole number that will go into both of the 2's for calcium and for oxygen. So naturally the highest whole number that would go into those is also 2. So when we reduce that, then that gives us CaO. Because remember, in ionic compounds we have to have a balance of charge. So if we have 1 calcium, then we need to have 1 oxygen, because calcium is a +2 oxidation state and oxygen has a -2 oxidation state. So we have to have equal amounts of those in order to have a balance of charge. So let's look at one more. Here we have aluminum nitride. So aluminum forms a +3 cation, or has an oxidation state of +3, and nitrogen has an oxidation state of -3. So just like in the last one, always we have to, when we do the crisscross method, so when we draw these arrows and we take the oxidation state of one down as the subscript for the other, we always have to reduce. Okay, so now what would be the highest whole number that would go into both of these 3's that are circled? And naturally that highest number would be 3. So we divide each one by 3, and that gives us the proper chemical formula for an ionic compound that would occur between aluminum and nitrogen, and that is ALN. So they will form in a 1-to-1 ratio. But we have to remember that in ionic compounds, we have to reduce that if possible. And we only do this in ionic compounds.
Well, this is going to wrap up our lecture on how to name ions and also how to name and write the formulas for what I like to call type 1 ionic compounds. Now, over the next few days, we're going to learn how to name and write not only these types of compounds that we talked about today, but some other more complex ionic compounds. So stay tuned for some more videos, and also make sure you're taking notes over this lecture. It would definitely help you in class when we work out practice problems. So it's really important that you pay attention in class over the next few days so that you can grasp the concepts that we're talking about in naming and writing these ionic compounds. So I'll see you tomorrow in class, and please bring in questions that you might have so that I can answer them. Thank you for listening.